This is Professor Dare of Science. This video shows how to calculate the expected value of a discrete random variable probability distribution using Microsoft Excel. In the first column are the values of the random variable x, the outcome values. The blue cells are data that you have to provide. The formulas are set up to go down through row 30. And if you only have data that fills part of the blue area, that's not going to affect the calculations because the blank cells are interpreted as zeros and they have no effect on this particular calculation. Next to each value is its probability. Over here is a check on the sum of the probabilities down through column B all the way down through row 30, and they should equal to 1. These blank cells just add 0, they don't change anything. If you exceed the blue cells with your data, you will have to change these formulas appropriately. The next cell here is the expected value, which is the same as the mean of this probability distribution. And it's calculated as a sum of products. The products are the outcome times its probability, and each of those products is added together to get the expected value. Again, the blank cells don't affect this unless you, again, exceed the area. You'll have to change the end of these ranges. This data here for this particular probability distribution has some meaning behind it that I'll explain. There's a few tips here. This represents a selling of a ticket where there are 1,500 tickets being sold. And some prizes are being awarded. There's one ticket out of the 1,500 which will award you $500. Why does it say $4.98 here in this data? Because the price of each ticket is $2. If you pay $2 for a ticket and you lose, then your outcome, your profit is -2. And the probability of that is quite high. 1,496 of the 1,500 are losers. Only 4 are winners. So you can see the probabilities do not have to be typed in like this. They can be formulas. 1 over 1,500 is how we got this probability here. And there's one ticket for this and one ticket for that. And one ticket, they all have the same 1 in 1,500 probability. This one is higher. And that's why these values here, $4.98, since you paid $2 for your ticket, if you win 500, your profit is $4.98. So this data on the surface just looks like some random data, but it actually represents something of interest and shows that you don't have to always enter the probabilities as their answers. You can use formulas that represent the probabilities. As you can see for this example, it's expected that you're going to lose money. Expected value is loss of $1.35. So the people promoting these ticket sales are going to make a profit. 1,500 times 2 is $3,000. They'll end up with a profit.